In today's video, we're going to look at counterexamples and truth values of conditionals. So in last lesson, we looked at the different variations of conditional statements. We talked about converse, inverse, contrapositive, and biconditional related conditional statements. But we haven't yet talked about whether or not we can know if these are true or false statements, kind of like what we did with our and or statements. And so to do this, we'll have to start looking at the actual meaning of what's in these sentences. And some of these we may be able to tell definitively, hey, these are true. And some of them, there may be some gray areas. And so related to that, the first thing I wanted to do was talk about counterexamples. And with that, we also need to know the word conjecture. And so a conjecture is going to be an educated guess or an idea based on previous examples. This is almost like a hypothesis, but you're making a statement, and a conjecture can be true or false. And it is up to us to determine, hey, is this a true statement? Or is this a false statement because of what facts? And so if we're proving that that is a false statement, that's when we're going to give a counterexample. And so it's going to be an example or a sentence or something that proves our conjecture, something that proves our idea wrong. So let's look at a few examples. And again, some of these are dealing with math and some of these are not. So let's look at our first one. So our first one, our conjecture is that x squared equals 25 if and only if x equals 5. So let's think about this. If we do 5 squared, well, yeah, 5 squared equals 25. But are there any other instances, any other examples where we can square a different number and get 25? Well, what about -5? So what if x was equal to -5? Well, then we could take that, plug that into a calculator, and we will find that -5 squared is actually 25. And if you plug that into the calculator, notice how when I wrote this, I actually put parentheses around that. So if you're typing this into a graphing calculator, or if you're typing this into a Desmos calculator, and feel free to pause the video at this point and try it out, when you do -5 squared or -5 times -5, you get out 25 as your answer. So that means that this conjecture is false. Alrighty, example 2, our conjecture is all teachers work at a school. What do you think, true or false? Now for this one, we may need to play around with our grammar a little bit. I am proposing that this is a false statement. Because, do you know of any teachers that don't work in a school? Notice I changed my grammar a little bit. Well, we definitely have teachers that work at home. That could be our counterexample. So some teachers teach from home. So they may work for a school, but they don't work at a school. Again, I know several teachers that do actually also work at Virtual Virginia. I actually know a couple teachers that only work at Virtual Virginia, which is not technically a school, it's an online learning platform. So we still had a counterexample showing why that was a false statement. All right, let's look at our next one. So example 3, if it's an even number, then its last digit is 2. What do you think, true or false? Personally, I think that's a false statement. Why do you think so? Or why do I think so? Well, aren't there any other even numbers that don't have a last digit of 2? Well, I could think of a bunch of them. How about 24 or 36 or 48 or 60? Anything with an even number in that second digit or the last digit is still an even number overall. The last digit does not have to be a 2. All right, then our last conjecture, every polygon has 5 sides. True or false? Well, again, if you're thinking it's true, then you're thinking through all of the examples, and every single time you see a polygon, it must have 5 sides. Was that true? That is actually false. And again, we need to provide a counterexample anytime we say something is false. So my counterexample is, what about a hexagon? It's a polygon. Because again, our definition of polygon is just many-sided figure. Technically, a polygon is anything with 3 or more straight sides. And then how many sides does a hexagon have? Well, it has 6. So there's my counterexample. Could also use octagon, decagon, dodecagon, triskaidekagon, if you want to look that one up. But lots of different counterexamples that you could use. Now, take a moment looking at these statements. They're all in different formats. So I kind of used an if-then statement for my counterexample in example 1. But example 2, example 3, and example 4, I just made a statement. Your counterexample does not have to be a conditional statement. It is just some fact or some example or some explanation of why your conjecture was false. And so when I'm looking at possible new ways to do problems, I'm trying to think of all these counterexamples of when things could go wrong. If I can't find a counterexample, well, then it must be true. But as soon as I find one counterexample on something, any methodology for doing a problem, as long as I find one way that doesn't work, I know that that is not a reliable method. Alrighty, second piece of what we need to look at is how can we predict the types of conditional statements that we talked about? So if we know a conditional statement and potentially a converse statement, how do we figure out if the biconditional is a true statement? And how do we figure out if the, if the contrapositive is a correct statement? And so these are actually very closely related. And so our 2 big rules that we now need to practice are, first, the conditional. So your original if P then Q statement that you may have written is always going to have the same truth value as the contrapositive. And vice versa. So if you're given an if-then statement that is absolutely true, then you know if you were to write the contrapositive statement, it is also going to be a true sentence. Second piece of what we need to look at, let me change my color. Let's change over to red. So the second one that we can talk about is the biconditional. And your biconditional statement, no matter which order you write it in, is going to be true only if both your original conditional and the converse of that conditional are true. So let's look at a few examples. And again, we may be able to poke some holes in some of these sentences, but I was trying to pick pretty straightforward ones that we could work with. So our first one is, let me move this up a little bit. So first one is our conditional statement. If it rains, then the flowers are happy. Generally, is that a true statement? Well, do flowers need rain to be healthy? Yeah, they need water and they need air. So if it rains, especially in the spring when we have all the flowers starting to grow, it's because we typically have more rain. So I'm going to say that if it rains, then the flowers are happy. True. Now, again, I'm ignoring the extra pieces. So let's not think about monsoon season right now. Just straight out, plain old rain makes flowers happy. So our converse statement. And how do we write our converse? And here's our reminder. If you look at the first two letters, CO for change order. So converse is flip your ideas. So if the flowers are happy, and again, I'm going to play with the grammar a little bit, then it rained. Because if it rained, they got some water, and then they must be happy. So would you think that that's a true statement? And again, we're ignoring the weird flash monsoon season. We don't get those too often. But if the flowers are happy, then it rained. Yeah, because flowers need rain. Okay. Biconditional. Again, we can write this in any order we want, but biconditional, keep in mind, it has that different phrase in the middle. So we kind of leave off the if, we leave off the then. So it rains if and only if the flowers are happy. And I have to use a little extra room, that's okay. So was our conditional statement true? Yeah. Was our converse statement true? Yes. Therefore, our biconditional is also true. So biconditional is true because the conditional and the converse were true. All right, let's write the contrapositive now. I'm going to switch my color to blue so it matches up. Okay, so our rule said that the conditional and the contrapositive will always have the same truth value. So let's write our contrapositive. So original was if it rains and the flowers are happy. Contrapositive, switch and flip. So if the flowers, oops, let's spell that correctly, aren't happy, then it didn't rain. So again, conditions for flowers and plants to be happy, they need rain and they need sun. And if they didn't have both, they're not going to be happy. So if the flowers aren't happy, then it didn't rain. They didn't get one of the things that they needed. So I'm going to call that true because the conditional is true. So again, for the biconditional to be a true statement, both the conditional and converse, either order of writing it, both have to be true. Sorry, I have a light here. Contrapositive is true if the conditional is true. Let's look at another example. Here we go, example 6 on the back. So this one I gave you slightly different order. So we started with biconditional statement. So before we can determine if that's true, what are we going to need to know? Well, we need to know if the conditional is true, and we need to know if the converse is true. So let's write those. And again, doesn't really matter which order we're looking at. Basically, it means no matter what order we read that statement in, it has to be true. So for my conditional statement, I'm going to start out by writing that just the same order that I see the biconditional in. So if it rains, then it pours. Sort of related to what we were just talking about. So if it's raining outside, does it have to be pouring? No. What if it's just sprinkling or that weird misty thing that's always kind of annoying? So if it rains, it doesn't have to pour. So I'm going to say that's a false statement. What if it's just sprinkling? And again, notice, if it's false, I'm giving a counterexample to show why it's false. Okay, my converse, again, CO, change order. So if it pours, then it rains. So if it's pouring outside, is it raining? Well, yeah, because that kind of goes in with the definition, because pouring is pretty much saying it's raining very heavily, but raining. Okay, so our conditional and our converse. One was true when one was false. So here's our biconditional, true or false. And because of these two, this is false because our conditional was false. And we need to know that because our last piece is looking at the contrapositive. Again, I'm going to change colors. So contrapositive, when we're writing the contrapositive, what statement should we always go back to? Always the original conditional. So we're going to take that conditional and use that to write our contrapositive. Switch and flip. So if it doesn't pour, then it doesn't rain. True or false? Well, again, what if it's sprinkling outside? That's still technically raining, but it's not pouring. So I'm going to say false because of the same exact counterexample that I used for the conditional. Alrighty, all pets are cuddly. So cuddly, you can hug the pets. They like to, hang out with you. They're nice and soft. So that's what we're thinking of with cuddly, something nice and soft and easy to hug and very comforting. So try pausing the video, try writing these out, and then unpause and see how we compared. Alrighty, so here's how I would look at this problem. So all pets are cuddly. Wait a second, it's not an if-then form. So kind of like when we were doing those Venn diagram problems, let's start out by changing that over to a conditional statement. So if it's a pet, then it is cuddly. So what do you think? True or false? Well, what are all the different kinds of pets out there? So if you have a cat or a dog, generally they're cuddly. My cats don't really like to cuddle that much, but that's okay. But they're, cuddly as an L. So those are fuzzy pets. And, sometimes you might have, lizards sometimes do like to hang out with their person because they're cold-blooded animals and we're a lot warmer than they are. But I can think of one counterexample. And my counterexample is a fish. Fish, not so much with the cuddly. Now, again, you might have been, so I haven't had the chance to do this, but I know you can go swimming with the dolphins and manta rays, and some of them are very personable and like to be around people and be touched. But yeah, those are different kind of animal. I'm talking like fish in an aquarium, you're not going to cuddle them. Okay, converse. CO change order. If it is cuddly, then it is a pet. Anything that you know of that's not a pet that could be cuddly? Well, what about a sweater? So when it's really cold, you might put a sweater or a scarf or something that's really soft and it just keeps you nice and warm. So I'm going to say, well, other things are cuddly, like a sweater or a blanket. Okay, biconditional. Again, what are we switching out in the middle? So it is a pet. I'm going to abbreviate. So again, you might see that every so often. If and only if it is cuddly. I can't spell today. Again, what do we need for a biconditional to be true? Oops. We need the conditional and the converse to be true. Unfortunately, they're not. So we have no true, conditional, or converse. So again, before we said that it wasn't true because only one of them were true. In this case, we don't have anything true. So if they're both false, it still makes a false biconditional statement. And then our contrapositive. So again, switch and flip from your conditional statement, always using the plain conditional statement to write this. So if it is not cuddly, then it is not a pet. What do you think, true or false? Well, yeah, are there pets that are not cuddly? Sure, we could have fish. Many lizards wouldn't be cuddly. I don't think something like a tortoise would be very cuddly per se, but multiple examples with what could be untrue. So again, we'll do our warm up next class. So please do ask any questions that you still have on here, and we'll look at a few more examples. And then after your quiz from lesson 1B, you will have a chance to practice this. Let me know if you have any questions.